Okay, for these notes, we are going to add and subtract to simplify radical expressions. We got, I think, 8 slides here, so it's a little bit more difficult than multiplying them, as you'll see, but we will practice this in class, and as always, raise your hand or make a note if you're watching this at home of something that you want me to further explain, or feel free to listen back. All right, so if we're going to simplify 3 square root 5 plus 4 square root 5 minus 2 square root 5, just like adding variables, we can only combine like terms, so we're only going to combine like radicals. What makes this a like radical is what's under the sign, under the radical sign. All right, so since they all have a 5, they are like radicals, and in that case, we can easily just add the coefficients or the numbers that are in front. All right, so we have 3 plus 4 minus 2. What is 3 plus 4 minus 2? It's 5. And then we keep the like radical, square root 5, in the answer. So the answer is just 5 square root 5. Again, if you were to put this in the calculator, you'd get a decimal. And then if you put 5 square root 5, you would get the same exact decimal in a calculator or in decimal, so you can check your work here. Okay, let's look at another one. 6 square root 7 minus 3 minus 2 square root 7 plus 4 square root 3. Now, you got to determine which are the like radicals. Which are the like radicals? So, we'll underline the like radicals. So we have a 6 square root 7 and a negative 2 square root 7. Notice I said negative 2 square root 7 because the sign stays in front of the term. And then we have a negative square root 3 plus 4 square root 3. So we combine those, the ones with the 7s, we're going to do 6 minus 2, and we would get 4 square root 7. And then we have a negative 1 square root 3 and a 4 square root 3. Okay, so it's like this is a negative 1 right here. So negative 1 plus 4 is a positive 3, and again, we keep the same radicals. And then this is simplified. So to simplify these 4 terms here, it simplifies to these 2 terms here. Again, you're combining the like radicals, the ones that have the same number under the radical. Okay, so if you were to simplify 5 square root 2 plus 6 square root 2 minus 4 square root 2, which would be your answer here? They all have a square root 2. So 5 plus 6 minus 4. You're just combining the coefficients or the numbers in front of the radical. 5 plus 6 minus 4. 11 minus 4 is 7. So this is the correct answer. Okay, make sure you circle that on your notes as the correct answer. All right, if you turn your notes over, basically I just have the PowerPoints there for you. All right, let's look at this word problem here. Find the perimeter of a rectangle whose length is 4 square root 6 plus square root 3, and whose width is 2 square root 3 minus 4. All right, so like I've always mentioned, when we have a word problem and this is the perimeter of a rectangle, I always say let's draw a picture. So you have a box there on your paper, just fill in the lengths and the widths. So 4 square root 6 plus 3 is a length. Make sure you put your other length down. And then 2 square root 3 minus 4 is a width, and make sure you put your other width. If we're going to find the perimeter of this rectangle, what are we going to do with all the sides? Add them up. So if we add these up, okay, we're adding the like terms. So we have a 4 square root 6 plus a 4 square root 6. 4 plus 4 is 8. And then we have a 2 square root 3 plus 1 square root 3 plus 2 square root 3 plus a 1 square root 3. Okay. And then we have a -4 and a -4. Let me see if I get my tool up here. Okay, so this -4 and this -4 at the end will combine to -8. This 2 square root 3 combines with this square root 3 with this square root 3, and there's a number just understood 1 in front of it. And then you have the 4 square root 6, we'll put 2 lines under that, with this 4 square root 6. So you're going to have 3 terms here, obviously, okay? So my answer comes to 8 square root 6 plus 6 square root 3 minus 8. If you don't understand how we got that, take a look. We combined the like terms. If still don't understand, then take responsibility and raise your hand and ask for me to come and explain how we got that. All right, if you understand it, move on to the next slide. Simplify. So we have 427 square root 27 minus 2 square root 48 plus 2 square root 20. So they do not have like terms, so you cannot add these up yet. Okay, this is where it gets a little bit tricky, and you need to make some notes here on this slide on your notes. Okay, we need to simplify each radical, which is what we've been doing. Okay, we've been doing that when we've been simplifying radicals. We find factors underneath, okay, that multiply to be those numbers. So I'm going to try to break it down a little bit in this PowerPoint for you. So if I break down each radical to what multiplies to be the number under the radical, okay, so we're going to simplify each radical. So we have, instead of 4 square root 27, we have 4 square root 93. All right. Instead of the -2 square root 2 times 48, we have 16 times 3. And then instead of 2 square root 20, we change to 4 times 5. These little squares should have X's in between them, or dots. Put dots there, okay, so that, oops, let me go back. Put dots in between so we know these multiply. Now, why do you think the letters or these numbers are in blue, highlighted in blue? That's because they are perfect squares, okay? 9 is a perfect square, and it can come out as a 3 because the square root of 9 is 3. So if I bring it out, remember these empty squares that you see here are, just put a dot in between, okay? So 4 times 3, and then this would be, the square root of 16 is 4, so it comes out, and that's 2 times 4, and then this blue 4, the square root of 4, comes out because the square root of 4 is 2. Okay, so now we have 2 terms that have like radicals. We could simplify this 4 times 3 to 12, and this 2 times 4 to 8. And then we can combine the 12 minus the 8 and put it with the square root 3 because those are like radicals. Okay, these are like radicals. Where is it? Where's my dot? There it is. All right, so when it says square root 3 and square root 3, those are like. Okay, so we combine 4 times 3 is 12, and put dots in between there. 4 times 3 is 12, and 2 times 4 is 8. So 12 minus 8. Okay, well here they wrote 12 to the third minus 8 to the third. Then this 2 times 2, combine it to get 4 square root 5. So now we can combine like radicals. We have the 12 square root 3 minus 8 square root 3, and we get the 4 because 12 minus 8 gives me this 4. And then the square root 3 comes down. And this 4 square root 5 is just tacked onto the end plus 4 square root 5. Remember, we can't combine these. This is the final answer. you can't combine because they are not like radicals. So you can't combine. All right, let's look at another example. All right, so we're going to try to pull out a perfect square. Pull out a perfect square from the 50, the 72, and the 98. Okay? And this is what it looks like. So you have 8 square root 25. 25 times 2. 25 is a perfect square. And then 72 can simplify to 36 and 2, and 36 is a perfect square. 98 can simplify to 49 times 2, and 49 is a perfect square. Remember, we want perfect, and these are dots in between here because we're going to multiply these. Okay, or that's how we get those numbers. The two numbers down here multiply to be it. When we pull out the perfect square, okay, the perfect square, or the square root of 25 is 5. The square root of 36 is 6. Square root of 36 is 6. And the square root of 49 is 7. Notice the 2 stays under, the 2 stays under, and the 2 stays under. Just like on the last example, we're going to multiply the numbers that are outside. Now we have 40, which is 8 times 5. Square root 2, 30, which was 5 times 6. And then we get the 14, or negative 14, because of a negative 2 times 7 here. They all have the same number under the radical, which means we can combine the coefficients. 40 plus 30 minus 14. The final answer is 56 square root 2. All right, the next slide, you have some, okay, these are answer choices, okay? So you are simplifying 5 to the third plus 4 to the square root second minus 3 square root of 3. So you're going to combine your two like terms, 5 square root 3, negative 3 square root 3. 5 minus 3 is 2. So we have 2 square root 3 plus 4 square root 2. Your final answer is this one. All right, and then the last one to do, simplify those. They do not have like, there's not like radicals there, so you have to simplify them. So let's see, 3 square root, are there any? There 4 times 3 plus 4 square root, and this would be 9 times 3. That equals my 27. All right, 4 is a perfect square. It comes out as 2, so we have 3 times 2 square root 3, and 9 is a perfect square, so bring down the 4. The square root of 9 is 3, and square root 3. So if you simplify that, you get 6 square root 3 plus 12. 4 times 3 is 12, square root 3. And now we have like terms, so we just add the coefficients, and we get 18 square root 3, which is my answer. All right, we're going to practice this. Again, you're not going to become good at it unless you practice it. So if you're looking at this and I'm not with you, then make notes of where you need help to review it. If I am with you and you're looking at this in class, raise your hand if you have questions. But again, we'll get some practice in class with it as well.